All right, hello guys. This is Mr. Heron looking at 2.2. Remember, the kind of the big idea here is looking at lines and kind of what happens when lines cross in geometry. So now this is kind of a step back. We're looking at slope. Slope was something that was pretty heavy in Algebra 1 and intermediate algebra. So now we're taking a look at it again, just to kind of remind you what it's about. So slope is your rise over your run. It is how fast you go up or down over how far do you go. So now ski resorts rate their trails by the difficulty level. One of the big ways they measure that is with slope. So the easier trails have a slope that ranges from 6% to 25%, where the tougher ones have a slope of 40% or greater. So what does this mean? So what does this mean? What this means is that the steeper the slope, the more dangerous the ski hill is. All right, so if you find slope in the coordinate plane, what you're doing is literally measuring how steep is this line. So what you need to remember is, how do I get from here to here, and what am I measuring that with? Well, you've got to look at where are these points located and figure out what they are. So letter A is going to be -2, +3. Letter B is going to be 4, 0. So my slope, then remember, is going to be y minus y over x minus x. Now it doesn't matter which one I go first, which one goes second, as long as I stay the same. Okay, and here's what I mean when I say that. So I can say 3 minus 0. All right, I can say this is the first y, this is the second y. But if I do that, I've got to say -2 minus 4. All right, these two come from the same point. These two come from the same point. All right, so 3 minus 0, 3. -2 minus 4, -6. So simplified, this slope is -1/2. And that's what it should be. So down 1 over 2, down 1 over 2, down 1 over 2. That is your slope. All right, it's down because it's going down when you read it left to right. All right, the technical, more elaborate mathematical way is y2 minus y1 over x2 minus x1. So that's kind of what the official way to measure slope. So if I take a look at the slope of these two, so looking at the graph, how did I get from J to K? Well, if I'm going, am I going up or am I going down? Well, I'm obviously going up, so that's what I measure first. So 1, 2, 3, 4, 5. So I went 5 units up. How many did I run right? 1, 2, 3, 4. So my slope is going to be 5/4. Number 2, this one is going down. So how far am I going down? 1, 2, 3, 4, 5, 6. That's going to be negative because I'm going down. How far am I running? 1, 2, 3. So my simplified slope is going to be -2. That's going to be how you pick it off of the graph. Aha. So a slope here. Am I ever rising? No. How far am I running? Doesn't matter. I could put 1. I could put 1,000. I'm just running forever and ever and ever and ever and ever. So, well, from N to P, 1, 2, 3, 4, 5, 6, 7. So that's 7 units. But that's still just a slope of 0. And it's a slope of 0 because there's no rise and there's all run. So there's no rise. That's why it's 0, all run. So that's going to be 7. So flip that around, though, look at number 4. I'm rising forever. So it's 1, 2, 3, 4, 5. But I'm not running at all. So that's going to be 0. All right. So the slope of this one is what we call undefined. It's undefined because when you look at the slope and you follow the rules, you're actually trying to divide by 0, and that's something you cannot do in mathematics. So that's kind of why we call that undefined. So let's take a look. Line B and R are parallel. B passes through 3, 6, -9, 2. R passes through 5, 4, 2, 3. Let's look at the slopes of these two things. So for slope of line B, again, y minus y, x minus x, so 2 minus 6 over -9 minus 3. So that's going to be negative 4 over negative 12, which actually simplifies to positive 1/3. It's positive because you have negative over negative, and those two cancel each other out. Line R passes through 5, 4, and 2, 3. So this is going to be 3 minus 4. This is going to be 2 minus 5. If I do that, I get negative 1 over negative 3, which is actually positive 1/3. Now, I could also flip that around. I could also say, you know what? 4 minus 3, 5 minus 2, that's going to be 1/3. That's the same idea. But notice something. The two lines have got the same slope. That is not a coincidence. And parallel lines have the same slope. Pause and play that back one more time, or listen once again. Parallel lines have the same slope. Okay, perpendicular lines follow a little bit different rules. So if I do the same thing, negative 5 minus 1 over negative 1 minus 1, that's going to be negative 6 over negative 2. That's going to equal 3. That's for line S. For line P, 1 minus 2 over 6 minus 3. That's going to be negative 1 over 3. That's going to be negative 1/3. So now, how are those related? They're related like this. Perpendicular lines have a product of negative 1. Let me say that again. Perpendicular lines, their slopes, have a product of negative 1. So if I multiply the two products together and I get negative 1 for an answer, that means the lines are perpendicular. It's what you call a negative reciprocal or an opposite reciprocal. So, two lines have the same slope if and only if they are equal. Two lines are perpendicular if and only if their slopes are negative reciprocals. Okay, so if I flip it over and change the sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. And I flip it over. So are the following lines parallel, perpendicular, or neither? So if I take line R, passes through here, so I want to take 1 minus negative 9 over negative 4 minus 7. So that's going to be 10 over negative 11. And line S passes through 4, 6, 15, negative 4. So I take negative 4 minus 6, and I take 15 minus 4. So it's going to be negative 10 over 11. Those two are technically the same because it's still just negative 10 over 11. Those two are going to be parallel. So graph the line that contains a point 30 and is perpendicular to the line that contains negative 2, 3, negative 3, and 2, 0. So let's figure out the slope of this one first. All right, so I've got 0 minus 3, 2 minus a negative 2. So that's going to be negative 3 over 4. That's the slope. So now negative 3, 0 is right here. So I want the perpendicular slope to this one though. Perpendicular to this. Perpendicular to this. Remember, flip it, change the sign. So the slope I want isn't negative 3 over 4. It's 4 over 3. That's positive. Okay, so graph the line. That's all I want to do. Graph the line. So now the slope I want is 4 over 3. My starting point is right here at negative 3, 0. So I want 4 up, 3 over. There's my line. That is the line that I'm looking at. I want the slope. Take the slope I found, flip it over, and change the sign. Graph the line that contains a point 5, 1 and is parallel to the point that contains negative 2, 4, and 2, 1. I think they meant to say line here. All right, so taking my slope, 1 minus 4, 2 minus negative 2, that's going to be negative 3 over 4. There's my slope. Now, since it's parallel, parallel means take the slope as is. So I go to 5, 1, that's right here. Negative 3, 4 means I go down 3 over 4, which I actually come off the graph a little bit, but I can also kind of go backwards. So I'll go backwards 4, up 3, and it should look something like that. Okay, so in application problems, the slope is often thought of as a rate of change. How fast are you changing over what span of time usually? Time can be measured in minutes, hours, years, doesn't matter. So in 1965, the city of Columbia, South Carolina had a population of 8,052. In 2012, it was reported that the population was 131,686. What is the annual rate of change? So think about this as 2 points. So 1965, 8,000 people lived there. In 2012, way more people live there. So those are your 2 points. That's your X, that's your Y. So your annual rate of change becomes 131,686 minus 8,052 over 2012 minus 1965. So what that's going to give you is this. So this is going to be 123,634 over 47. So now here's what the slope says right now. It says that over a 47-year period, the growth grew. They got more people for 123,634. So 47 years, 123,634 people moved into Columbia, South Carolina. But that's not what they want. They want the annual rate of change. They want the annual rate of change. So what I need to do is I need to actually divide this. So 123,634 divided by 47, actually divide that, and you get 2630.5. So you get an average annual increase of 2,630 and a half people. So that is kind of your annual rate of change. But all you're doing is taking slope and then you actually divide it. So in 2013, 500 million songs were legally downloaded from the internet. In 2011, 200 million songs were legally downloaded from the internet. Find the slope and interpret its meaning. Okay. So 2011, 200 mil. In 2013, 500 mil. I'll just leave it at 500, 200, and we'll assume I'm talking about millions. So if I take 500 minus 200, I take 2013 minus 2011. So that's going to be 300 over 2, which simplifies to 150 over 1. So what does that mean? That means that every year over that 2-year period, 150 million songs, 150 million more songs were downloaded. So if this trend continues at the same rate, how many songs will be legally downloaded in 2015? Okay, so 2015. So for 2013, I had 500 million. So what would it be in 2014? What would it be in 2015? Well, I add 150 and I add another 150. So that gives me 800 million songs downloaded legally in that time period. So in 2000, annual sales for one manufacturer of camping equipment was 48.9 million. 2005, and the sales were 85.9 million. If sales increase at the same rate, what will the total sales be in 2015? So once again, 2000, it's 48.9. 2005, it is 85.9. And what's it going to be in 2015? So that is a difference of 10 years. It's just good to make note of that because it can help us later. So 85.9 minus 48.9 over 2005 minus 2000. So that's 5 years. 85.9 minus 48.9 is 36. So that is an annual growth of $7.2 million per year. Okay, so $7.2 million each year. That's what their average increase is. Okay, so if I want to know what it's going to be like 10 years down the road, I'm going to take 7.2 times 10, and that's 72. And I'm going to add that to 85.9. All right, so 85.9 plus 72. So in 2015, if this trend continues, it's going to be $157.9 million. Okay, that's what you're looking at. How is that rate applied? That's all I got. We will talk to you soon. Thank you very much.